Now let's see theorem number 27. Proof is very easy. See, what is statement of this theorem? If P is a prime. In number theory, P always denotes a prime number. Okay. And P divides A1, A2 up to N. This is the generalization of theorem number 26. We have already seen theorem number 26. Okay. And this is generalization, means in theorem 26 there are only two factors, A and B. Now here there are more than two factors. If P divides A1, A2, An, then P divides at least one factor AI of the product that is P divides AI for some I where 1 is less than or equal to I is less than or equal to N. Okay, very easy proof. So see the proof. We already know, let P be a prime number. Okay, P be a prime number. Okay, and P divides A1, A2 up to An. And I have already told you, in mathematics most of the theorem will prove by mathematical induction or by contradiction. Yes, so here we apply induction method. We apply induction method. I have already told you what is induction method. Induction method means proof for this statement is true for n is equal to 1. Yes, and assume for n is equal to k. Assume for n is equal to k, this statement is true, and show that what? Show that for n is equal to k plus 1, this statement must be true. Yes, so by induction for n is equal to 1, the theorem follows trivially. Yes, this theorem follows trivially. Understood? Yes, means if we take A1 n is equal to 1, so P divides A. Of course P divides A. This is true. Yes. After that, assume it is true for some n belongs to n, or put here k belongs to n, same meaning. So take here instead of k n belongs to set of natural number. Yes, n, this small n is the element of set of natural number. Consider the product A1, A2 up to An plus 1. Okay, of n plus 1 integers, and P divides A1, A2, A3 up to An plus 1. Okay, now P divides A1, A2 up to An plus 1, which is equivalent to P divides, we can write this as, here is A1 up to An and An plus 1. Okay, so here A1, since A1, A2, An, this product we can call as, suppose, B. So we can write here P divides B into An plus 1. Okay, so by theorem 26 by above theorem, by theorem 26. What we can say? Either P divides B or P divides an plus 1. Yes, read the theorem number 26. What is statement? If P divides AB, what is the statement of theorem 26? If P divides AB, this implies P divides A or P divides B. Yes. Yes. See, this is the theorem number 26. So by theorem 26, if P divides B, if P divides B into an plus 1, this implies what? Either P divides B or P divides an plus 1. Okay, understood? After that, call this as equation number 1. P divides B or P divides an plus 1. Call this as equation number 1. But by induction process or by induction hypothesis, yes, by induction hypothesis, P divides B. Yes, and what is value of B? B is A1 up to AN, product of A1, A2 up to AN. Yes, so we can write P divides AI for some I. Yes, for some I where this I is greater than 1 and less than or equal to n plus 1. Yes, less than or equal to n. Okay, then equation 1 gives P divides A1, A2 up to AN plus 1, which is equivalent to P divides AI. Yes, for some I, where 1 is less than I is less than or equal to n plus 1. The theorem follows by induction, and hence we have proved the above statement of this theorem. Yes, understood? काय केलं आपण? n इज इक्वल टू 1 साठी आपण प्रूव्ह केलं, त्यानंतर n इज इक्वल टू k साठी ॲज्युम केलं आहे. तो k न घेता आपण इथे काय केलं आहे? nच घेतलेला आहे. येस, आणि त्यानंतर n प्लस 1 साठी आपण हे स्टेटमेंट प्रूव्ह करून दाखवलं बाय युजिंग अवर assumption that for n is equal to k it is true. Understood? P by induction hypothesis P divides B, म्हणजे P यापैकी एका याला डिवाइड करत आहे. येस, सो फ्रॉम इक्वेशन 1 P divides A1 A2 अप टू an प्लस 1, यापैकी कोणत्याही याला P डिवाइड करते. याचं मिनिंग काय की हा I कुठून कुठे व्हॅरी होतं? I varies from 1 to n plus 1 and hence we have proved.